Today we're going to talk about linear equations in 3 dimensions, section 3.5.
That sounds like geometry.
The thing we're focusing on today, up till today we've been talking about 2 dimensions, as in we're talking about x and y. Today now we're going to start talking about 3 dimensions. And again, why is that important? Well, we live in a 3D world dealing with 3 dimensions all around us. Okay, so today we're going to talk about linear equations in 3 dimensions, section 3.5. Vocabulary here. Coordinate space. This is what's going to be new to us. Coordinate space is adding a third axis, the z-axis, to the xy coordinate plane. Okay, so now we're going to add the third axis, which is the z-axis, to the xy coordinate plane. And this now gets us what we call ordered triples. Up to today, we've been talking about ordered pairs. Pairs meaning 2, like for the warm-up, we had an answer of 2, 1. Now we're talking about ordered triples, which is in coordinate space, you graph points of the form x, y, z. Notice, it's still in alphabetical order, x, y, z. Okay, so ordered triples, now I have 3 coordinates. Or I have 3 axes here. Here's what this looks like here. I have the coordinate space. In a 3-dimensional coordinate system, the x-axis projects out from the paper and the z or the y and z axes lie in the plane of the paper. This right here, does everybody see this line I'm circling here? You kind of have to use your imagination and say that line is coming out of the wall at you. Okay? That's what gives me the x-axis. Again, this line, if I use a meter stick here to project, that'd be like that is coming out of the wall at you in 3 dimensions. Now, why is that tough to see on this? Who can tell me why?
Because the paper's not 3D.
The paper's not 3D. I'm talking about a 3D space, and I'm writing on it on a 2D paper. So you kind of have to use that imagination of thinking this coming out. And again, we're talking about ordered triples. Ordered triples are in the form x, y, z. And to graph them, we're going to use some kind of locate or point locators to go through that. So like 3, 2, 4, I would move what I call 3 units forward, 2 units to the right, and then 4 units up to graph that. And here's what that looks like here. So the xy coordinate plane, that's what the coordinate plane is before we've talked about it here today. And now here's the coordinate space, so 3-dimensional coordinate system. Again, my x-axis is coming out at us. Okay, you gotta imagine the x-axis as coming out of the wall or out of your piece of paper at you. Notice this is my x positive direction, x negative, y positive, y negative, z positive, and z negative. So here's what I'm looking at here now. The x-axis. When I talk about x-axis, I'm talking about I'm going to go forward or backward. I'm going to go forward if it's a positive number, backward if it's a negative number. Okay? So again, if I look at the diagonal there, forward positive, backward negative. Y-axis, left negative, right positive. So I'm going to go left if it's negative, right if it's positive. And then my z-axis, I'm going to go up positive, down negative. Okay, so I can describe where these points are located by if it's forward or backward, left or right, up or down. So for instance, let's say I give you the problem 2, 1, negative 3. First off, I'm looking at my x-coordinate, 2. Would I go forward or backward 2? I would go forward 2. It's positive, right? So I'm going to go forward 2. Then I look at 1, left or right. I'm going to go right 1. And then I look at negative 3, up or down? Down 3. So that's the way I can describe where that point is located. It's forward 2, right 1, down 3. What if I gave you the coordinate, negative 1, 2, 1? Negative 1 says I'm going to go back 1. 2 says I'm going to go right 2. Positive 1 says I'm going to go up 1. Yeah. So that's what it's talking about. I'm going to go back 1, right 2, up 1. Okay? So again, that's how I can describe these points. Here's what it looks like now in the coordinate space. So here's my coordinate space over here. Okay? Remember, x is my diagonal. Got to think of the x as coming out of the wall at us. I'm going to write the coordinate 3, 0, 0. So first I'm going to look at 3. Am I going to look at forward or backward? I'm going to go forward 3 coordinates. 1, 2, 3. Does everybody see I went forward 3? Would I go left or right at all? None. Up or down? None. A is actually going to be located right there. There's A. Forward 3. Not going to go left or right. Not going to go up or down. That's it. What about B now? Negative 1, 1, 2. Let's look at negative 1. Am I going to go forward or backward?
Backward.
I'm going to go back 1. Right or left?
Right.
Right 1. Up or down?
Up 2.
So I'm going to go up 2. So if I look at it, B should give me a coordinate about right there. Let's try C. I'm going to start with 2. Forward or backward?
Back and forward.
I'm going to go forward 2. Negative 1, left or right?
Left.
Left 1. 4, up or down?
Up.
So C should give me a coordinate about right there. Try the next ones. Try D, E, F, G on your own. Take a couple seconds to try those 4 on your own. All right, let's look at number D, or letter D here. Negative 2, 1, negative 4. Katie, negative 2, forward or backward? I'm going to go back 2. 1, left or right? Negative 4, up or down? Would you agree D should be somewhere right there? Nice job. That's D.
God bless you.
E. Beast. Forward or backward? Nothing. I'm just going to start there. Left or right, beast? Nothing. I'm still going to stay there at the origin. And then 2, up or down? Up 2. E should give me the coordinate about right there, right? Nice job. F. Venice. Forward or backward?
Nowhere.
Left or right?
3.
Left or right?
Left. And just chill.
Then I'm just going to chill right
I
there.
got this one. I got this one.
There you go. I'm chilling.
I got this one.
Crump. Forward or backward?
Backward.
Left or right?
Left.
Up or down?
Down.
Now, where does it appear this coordinate's actually located?
2.
It looks like it's at the origin. Is it actually at the origin? No. Okay. Yes, on a 2D paper, it might look like it. Okay. But again, if I get my meter sticks back out here to show how this would look in a coordinate space, okay, I'm going to go back 1, left 1, down 1. That point's really located like somewhere down here. Okay, so you have to actually use your imagination to think about where this point's actually located. Does that make sense for everybody? The tough part is we're on a 2D paper here, and we're talking about 3D space. Okay? So yeah, those are the coordinates there. Nice job. Last part we're going to talk about today is we're going to talk about finding intercepts. Do you remember finding intercepts on x, y's? If I wanted to find the x-intercept, what would I cover up?
Y and Z.
Well, before this, yeah, I just covered up the y. Now, let's say I want to find the x-intercept. What do you suppose I'm going to cover up?
Y and Z.
Yeah, cover up the y and the z. What would my x-intercept be?
6.
6, 0, 0, right? If I want to find my y-intercept, what am I going to cover up?
The X and Z.
What's my y-intercept?
0, negative 3, 0.
0, negative 3, 0. And if I want to find my z-intercept now, what am I going to cover up?
The other 2.
And I get
0, 0, 4.
0, 0, 4. Okay? And then, yeah, I'd connect all my dots basically there. So let's look at number 1 here. It says, sketch the graph of 2x plus 2y plus 4z equals 8. First thing I want to do is I want to find my intercept. I want to find my x-intercept. What would my x-intercept be, Drew?
4, 0, 0.
4, 0, 0. Because y, I'd cover up my y and I cover up my z, right? Good. What about my y-intercept? What would my y-intercept be? McCoolidge.
0, 4, 0.
Nice job. 0, 4, 0. I guess I forgot to plot the first one. 4, 0, 0 should be down there. 0, 4, 0 should be there. And then I need to find my z-intercept. What would my z-intercept be? Beast. So it's the coordinate there. And last thing I'm going to do is I'm going to connect them and then I would shade my plane. Now, why am I shading the plane here? Because again, if you think about my three-dimensional space, the part that cuts through is like a piece of paper. Think about a piece of paper cutting through all those coordinates. It's giving me a plane. So I'm showing where that plane comes through. Okay? And that's why I shade. I'm just showing the plane that's coming through there. Take a couple seconds, try number 2 on your own. Find the intercepts, plot them, and give me the plane. All right, let's look at this here. So first thing I'm going to do is I'm going to find my x-intercept. What would my x-intercept be, Bennis?
300.
300. So right there. Then I want to find my y-intercept. Crump, what's my y-intercept?
3.
So as a coordinate?
0. 3. 0.
Nice shot. And Jace, what's my z-intercept? 0, 0, 3. Nice job. So again, I plot those coordinates, connect them, and I shade everything in. And there it is. Nice job. Last one. Try this one on your own. Again, find the intercepts and shade the plane. All right, so number 3 here, I'm going to find my intercepts. King, what's my x-intercept?
400 or negative 400.
Negative 400. Hannah, what's my y-intercept? Zero what? 0, negative 2, 0? Divide, right? So, and then my z-intercept would be what, Allie? 0, 0, 4, nice job. So I did my x-intercept, back 4. Y-intercept, left 2. Z-intercept, up 4. Connect them. And then I shade them. And there's my plane right there. Nice job. That's it for today. Here's your assignment.